evening. You are watching Integrated Engineering Design video presentation. This is the team members of Evo Designer. Assalamualaikum, my name is Madya and today I will be presenting chapter 1. The most important thing in this chapter is, do you know what is ventilator? Ventilator? Ventilator. Yup, ventilator. Ventilator is a mechanical breathing assistant machine that helps to deliver air in and out of the lung to a patient who has a respiratory failure or they have difficulties in breathing. The concept of the medical ventilator is taken from the bag valve mask (BVM), which is also known as ambu bag. Ambu bag is used as a manual resuscitation kit for medical professionals in and out of hospitals such as ambulance. When the bag is squeezed out and re-inflated rapidly, the air is forced in and out of the lung. This is the mechanism of the ambu bag. Fever, cough, and shortness of breath are some of the COVID-19 symptoms. At the end of 2019, the spike in the cases has caused inadequate access to respirator due to high demand. This project is an upgrade version from a previous existing goods. The modern mechanical ventilator that is commonly used in intensive care units are very complex and expensive. Do you know that a ventilator costs approximately 130,000 each? Yes, 130,000 each. It is so expensive. Besides that, it is difficult to manufacture the modern medical respirator as it is made up of hundreds of smaller parts produced by different companies around the globe. Meanwhile, for the ambu bag, although the mechanism seems very simple, it is highly technical and complex, which any mistake would result in injury or death due to overinflation or overpressurized of squeezing the ambu bag. That's why we decided to come out with this project. We are designing this portable mechanical ventilator that can support 2 lives. Hence, this product will eventually minimize the cost of buying an additional ventilator machine, and it will also overcome the space limitation. The feature of this product will significantly help to overcome the shortage of current ventilator in hospital, especially in the underdeveloped area. That's all from me. I'm going to pass this presentation to Mami.
Thank you Hidayah for the explanation of chapter 1. So I'm Amir Farhan. I will explain about chapter 2. So the first step is we need to find patterns that are relatable with our product. So as you all can see on the slide, we found out 3 patterns. So for pattern 1, pattern 2 and also pattern 3. It's all the same for all the patterns that they use the bag valve mask or BMV, and the pattern and all the pattern uses electric. Our product only use battery and it is portable on our product, but not all the 3 pattern. So for the pattern 1, 2 and 3, they can only support 1 person at one time, while our product can support 2 people at one time. So after done searching for the pattern and compare our product with the pattern existing, we need to find out the existing product in the market and we need to do the benchmarking. So for the next slide is the benchmarking. We found out 3 products that are in the market right now. So the product 1, product 2 and also product 3. Product 1 and product 3 uses the mechanism of suction where they suck the air and transport it to the patient. So meanwhile for product 2, it uses the manual squeezing. It requires the human energy to squeeze the BMV. So product 1 and product 3 use electric and also battery pack, while product 3 does not require any power source. So for product 1 and product 3, it is expensive and heavy. Thus it can be portable, but it's not convenient because it is very heavy, while the product 2 is lightweight and more affordable price, but still expensive if you look at the product. So product 1, product 2 and product 3, all those 3 products only can support 1 person at a time, while our product can support 2 person at a time, and the price is more affordable, lightweight and also very portable. So after doing the benchmarking, we need to identify the market needs. So we use the platform of Google Form, and we have a total of 100 respondents. So after that, we analyze the survey using the QFD or quality function deployment. So after that, then we can come out with the customer requirement. That is, the first one is low in weight, no electricity dependent, easy maintenance, low level of noise produced, and also can compress 2 BMV at the same time, and the price should be reasonable and affordable. So that is all from me, Amir Farhan. Linesh, you can take over from here. Thank you.
Thank you, Amir. My name is Linesh Chandran. Today I will explain about chapter 3, which is conceptual design. In conceptual design, there are 4 processes, which is define problem, gather information, concept generation, and evaluating concept. Function decomposition analysis is the final method in clarifying function, where it helps to identify whether the functions are connected. In function structure, there is a block diagram dissipating flows of energy, material, and signal as labeled arrows taking part between function blocks. In slide, I've attached function structures black box, function structure transparent box, and function structure analysis. In function structure, firstly we will turn on the power, which is powered by the battery. As we switch on the switch, the pusher will start to pump the MB back by pushing it downward. By controlling the speed of pusher, we can alter the speed by using the speed turner. After switching on, we can see display of pulse oximeter at the reading screen, which is located at the front frame of our product. Thus, the pusher pushes the MB back, so it will supply oxygen to the patients through expiratory valve. The method chosen in the concept generation for the project is morphological chat that includes brainstorming. This method makes the process to find a solution for a problem easier. And the next process is concept evaluation, where we will start by evaluating the concept developed for the lowest level of function decomposition. As in slide, in the right side is conceptual selection of our product, which is with its essential function and its alternative, which is part of concept evaluation process. Lastly, above are our product sketching. Clockwise from bottom are sketching 1, 2, 3, and 4 respectively. That's all from me. Now I'll pass it to Shazwan for the explanation on chapter 4.
I'm Muhammad Shazwan bin Hassan. Metric ID AD160182. Actually, our product, the material that used, which is the body frame, is aluminium. Okay, and the pusher also aluminium, because aluminium is the very affordable price in the market for material type. And then we don't need to use stronger material, because the force needed in our product is not too big, which is the pusher. The pusher and bag do not require very high force, so we will only use aluminium. This is the cluster element of schematic diagram of our product, which we have power setup, switch, battery pack, motor, and transmitting movement, bearing to shaft, shaft to gear, gear to pusher rod, and then lastly the oxygen transfer, which is pumping of empty bag, oxygen flow through pipe, FS, respiratory valve, and oxygen delivered to patient. Okay, next we will go to part of calculation. Okay, firstly, basically the calculation we will determine the empty bag capacity. Next, calculate the theoretical power requirement for worst case scenario, and then determine the force needed for the pusher to push the empty bag. Next, we calculate after we determine the force, we will need to calculate the power requirement for our product, because we want to choose the motor, and then the calculation of gear set, and then selection of gear. That's all from me. Thank you.
A good day to everyone. My name is Muhammad Ammar Haziq. So today I will talk about chapter 7 regarding sustainability and environmental considerations. Okay, so on chapter 7, related to sustainability and environmental consideration, there have been like 2 main subtopics that on this chapter. The first one will be life cycle assessment framework, and the second one will be concept of sustainability itself. So on the life cycle assessment, there are 4 main stages. It include the first one, the goal and scope definition of the project. In this stage, we are determine the objective, the functional units, the limitation of the boundary of the product. On the second stage, the inventory analysis. We are performing data collection, inventory analysis that give an information regarding the materials and energy flow within the system of the product. This is very important because the extraction of the raw materials and emissions to the environments we get from this raw data, it may be influenced the system definition because the correct data will result in correct outcomes. They are on impact assessment because there is this invention we are expected to give a big impact, not just for the human needs but also taking considerations towards the correlations towards the impact of environmental itself. On the sustainability of the concept itself, we are touching on the 3 main subtopics. Socials, it means that this portable machine ventilator is a project that helps the social aspect among the patient COVID-19 due to its low cost of product fabrication, helps to ease the jobs of the job scope of the frontliners by reducing the assets and energy used to treat the COVID-19 patient. On the environmental aspect, this machine does not produce any waste products from its mechanical aspects. It does not produce any products such as smoke that leads to air pollution, and also for the economy, the low cost maintenance will minimize the total operational cost of this product.
Okay, the total cost for one product is 1,557 ringgit. The marketable strategies, of course, firstly we need to understand the customer need. We need to know their demand, and then we analyze the existing product in the market. We analyze their advantages, disadvantages, and we do the remix of the information and idea, and we create our product. For the budget, of course, also we analyze the price of existing product, and then we do the education plan, and that's how we do our product sale. Our product description of portable ventilator machine assembled by us, Evo Designer, and our main material is aluminium, plastic, and metal. And next we go to the SWOT analysis. Strength of our product is user-friendly, and can support 2 patients at one time, and very easy to handle, not complex. And our weakness is maybe possible to get customer dissatisfaction because our product is very mini one, a very simple one, depends on selected material, and low production time. Our product opportunities able to market in the world, easy to obtain spare part. Threats is supply depending on demand. Machine have no security 24 hours. That's all for me, thank you.
Thank you, Shaswan. Now I'll present about conclusion and recommendation. Our product will significantly help to hold urgent demand for ventilators that exceeds national capacities due to rapid and widespread of COVID-19 in Malaysia. Our product also will eventually minimize the cost of buying an additional ventilator machine because the current ventilator machine can only accommodate to support only 1 life. Meanwhile, our product can support 2 life in 1 machine. Some suggestion could be made for MB bag from a tough and durable plastic such as high impact polystyrene and polyethylene tetrafractaline glass, which is called as PETG, to boost its lifetime and durability. Another suggestion is by providing buzzer to generate audio alarms in case the system does not work correctly or the battery is low. Furthermore, a recommendation of 2 LEDs such as red, for example, red and green color, that can indicate the battery status when high or low level of charge. Thank you. That's all from me.